Again, we will be working with the implicit equation 4y squared minus x squared plus 2x is equal to 2. And we know that the derivative dy dx is equal to x minus 1 all over 4y. We still want to find particular points on the graph of this curve. This time we're dictating a y-coordinate, y equals 3. And then once we have points, we're going to again want to find the slope of the tangent line at these points. So since we're given a y equals value, we need to plug that in for y. And so we have 4 times 3 squared, plugging 3 in for y, minus x squared plus 2x equals 2. And so we've got this equation that we're working with, so we see now that the only variable is x. So let's go ahead and continue working with this. We've got 4 times 3 squared, so that would be 4 times 9, which would be 36. 36 minus x squared plus 2x is equal to 2. So looking at this, we need to be able to solve for x. The problem here is we've got an x squared term and an x term. So this is a quadratic in x. And of course, with quadratics in x, we always have the quadratic formula that can help us solve this quadratic equation. So to be able to use the quadratic formula, we need to get all of our terms on one side equal to 0. So let's move all the terms to the right-hand side, because I like working with positive coefficients on the x squared term. So when we move everything to the other side, we add x squared to both sides, leaving us with x squared. We have to subtract 2x from both sides, leaving us with negative 2x on the right-hand side. And then on the right-hand side, we have a 2 sitting there, and we need to subtract the 36. So 2 minus 36 would then be negative 34. So there's our quadratic equation, and we've got the quadratic formula to be able to solve for x. So x is equal to the negative b, so negative b would be the negative 2, plus or minus the square root, so we have plus or minus the square root, of b squared, b is negative 2 again, so we have negative 2 squared. Notice that my negative 2 I do have in parentheses there, because we really do mean the negative 2 times itself for the b squared there. So b squared minus 4 times a times c. So 4 times a is 1, and c is our negative 34. And all of that is over 2a, so 2 times 1. So we have a bit of work to do to clean this up. As we do that, we've got the negative 2, so that would be a positive 2. And we have plus or minus the square root. And when we do this, we've got negative 2 times itself, so that would be 4. 4 minus 4 times negative 34. So the two negatives there would change to a positive when we do the multiplication. So we have 4 plus 4 times 34 under here. And all of that will be over 2. Let's make this line a little bit shorter and keep going. So we have 2 plus or minus the square root of, when we do that arithmetic underneath the square root, we would have, well, first what I would notice here is we have a 4 plus a 4 times something. So really we have the common factor of 4 that we could pull out and have a 1 plus the 34 left over when we factor the 4. Now, that may look very random, but remember, in the end, we're going to have a fairly big number under the square root, and we're going to need to see if there's any perfect squares. Well, I can be smart about this because 4 is a perfect square, and it's a common factor between the term here that's 4 plus the term here that's 4 times 34. So now, when I continue to clean this up, let's move up here. When I continue to clean this up, I've got the 2 plus or minus. When I pull the 4 out from the square root, I take its square root. So that would be 2 root. Now 1 plus 34 would be the 35 under the square root, all over 2. So now looking at the top, we now see 2 terms separated by the plus or minus, and each one of those has a common factor of 2. So if we were to pull the if we were to pull the 2 out front, factor it out, we'd have a 1 plus or minus root 35, and then all of it's over 2. Now the 2 over 2 is going to cancel, leaving you with just 1 plus or minus root 35. So we've got to put these together as points again. This time we were given the y value for each one, and we solved for x. So when we solve for x, we have the 1 plus root 35, and we have the 1 minus root 35 as our two x values. They're each paired with the y value of 3 to give us our points. And notice that, again, all we've done here is algebra. We haven't dealt with the derivative at all, which is our calculus concept. And so, again, we're ready to do the calculus by plugging into the dy dx that we already know. So dy dx evaluated at the 1 plus root 35, comma 3 is going to be plugging in the 1 plus root 35 into the top, where x is, and then we subtract 1 from it, all over 4 times 3. So here, the parentheses that I put around the value we had for x don't really need to be there because we just have terms that are added and subtracted, and we don't have like a minus sign that we need to distribute. So we have a 1 plus root 35 minus 1. The positive 1 minus 1 cancel, leaving us with root 35 on the top, and we have 4 times 3 on the bottom, which is 12. So that would be the value of the slope of the tangent line at that first point. And we can do the same for the second point, and again, the algebra is going to be very similar. So we have the evaluation this time at 1 minus root 35, comma 3. And when we plug it in, again, on the top, we've got this time 1 minus root 35, still the minus 1 coming from the dy dx definition, all over 4 times y, and the y value is 3. So again, we have a 1 minus a 1 situation, leaving us this time with the negative root 35 on the top, and we have a 12 on the bottom. Let's see if we can make that look a little bit cleaner here. We've got the negative root 35 on the top and 12 on the bottom. So that will be the slope of the tangent line to the curve at the second point.